Okay. How we doing? Before I start, who's in, who's out, so that I know who to bug. In, in, in. You in? You're in. Luna's in today. She was pretended to be in yesterday. Although, I mean, she pretended to be out yesterday. Today she's in. That's exciting. All right. So, does anybody remember what a closure is? Okay, that's good. All right, so there's a few things that we need to remember when we're dealing with closures, and with those, we are going to talk about them a little bit one by one. I don't think the lecture will be particularly long today. All right, so the first thing we want to remember is that functions, or this is like important to remember, functions can refer to variables defined in outer scopes. Okay, this is the first thing we have to remember when we think about closures. That our functions can refer to variables defined in outer scopes. Let's see what an example of that might be, right? So let's say I have let x equal, we'll just say 5, and then I have a function called add number, takes in a number, and I can return num plus x. Is this going to work or not work? Yeah. Add number, and I'll pass in 6. Okay, what do we think? All right, we get it. So that's really weird, right? Because well, how does add number have access to x? Where's x? Yeah, Trey. So it's not technically a global variable, but I like that idea, right? But it's outside of the function, right? This function, when this function was created, it has the scope available to it, has access to any variable within its scope. Whenever a function is created, it has access to all variables within that function's scope. Okay, so this is a matter of scope. So as you can see, our x is out there, but we've also included it inside of our function. So this is an example of a closure at the most basic. Okay. Any questions on that? Okay. Cool. So number 2 is closures can outlive the function that creates them. All right, so that seems kind of like a weird thing, and we can talk about that. So an example of a nice function here, I'm going to use an example from this book here. It's called Effective JavaScript. Great book for anyone who's interested in. So this is, I'm going to go through a couple examples. So let's say I have a function called make sandwich, or sandwich maker, let's say. Sandwich maker. And it takes no arguments for now. And I would say I'll have a magic ingredient. So I'm just going to write an ES5 because that's what the book has. But I guess I'll use let, doesn't matter. And I'll say let magic ingredient. And I'm going to say peanut butter. Okay. And inside of this function, I'm going to declare another function called make. And this is going to take in a fill-in. And it's going to return magic ingredient plus the word and plus fill-in. And then down here, I'm going to call make. I'm going to pass in like jelly. So if I call sandwich maker here, what do we expect to happen?
Are you not returning make?
I should return make.
You have to. I'm not.
Yeah. It's about right here, right? Yeah. Great catch. Trey, thank you. So Trey says it's going to return the string, peanut butter, and jelly. Agree? Okay, disagree? Don't know, not sure. Okay, so this is kind of the same as our first example here, if we think about it, where we had this function that used a variable that was declared outside of it, but was already within the same scope. So for this one, we have a function, which is that gets fired here, that grabs the magic ingredient, and the filling that gets passed in. So Trey, you got that, right? So this is like more of another example of the very first one. But what's interesting is I can make a little adjustment, and instead of passing make here, I could just return the function. I could return this uninvoked function, right? And so, well, why is that interesting? Well, okay, I could say let fun, I'll say fun make, and then if I say fun jelly, what's going to happen? What do we think might happen with this slight change to our code?
Same thing.
Same thing. Okay, how come?
Because you just declared sandwich maker as a variable.
Yeah, so okay, so if I console log right here, fun, how about, and I comment this on first. What are we going to print? We're going to print a function instead. Okay, so let's run this first, and we'll see that it says, yeah, we have this make function, because this is what we returned, right? We just returned this function called make. So now our fun, this variable that we created, is essentially this function, right? Now this is really what's interesting here, because now if I pass in, so if you think about it, sandwich maker here is already fired. It's already returned, right? So this function, sandwich maker, has been run. It's essentially done, right? So this is where our number 2 comes in, which are closers count with the function that creates them. So that function, sandwich maker, is died, so to speak. Like it's done running. But we still have this fun, this thing that last function returned. So if I uncomment this out, I think we're going to be pretty pleased, right? We're going to get what we want. Because it's remembering, it will remember all of the variables that were within the scope. Yes, Johnny.
What if the sandwich maker, you have an argument?
Yep, we're going to get to that. For sure. So this is kind of cool, right? So like, what about if I said, instead of jelly, I said, or maybe I can log both things actually. So hang on. So if I go console.log, I say console.log fun bananas. What's going to log? What are we going to have log to the screen now? Yeah, feels intuitive, right? That's a good job, Janelle. Janelle's peanut butter and jelly, peanut butter and bananas. Should have done this before lunch, right? Getting hungry. Right, so the point of this is that it's using the same function, and that this is remembering the variable. That's all that matters. Even though fun has already run, right? Sandwich maker has already run. We're not calling sandwich maker again. We're only calling it the one time. But even though we're calling fun with different variables or arguments being passed in, it's able to remember what that past argument was. So that's pretty cool. Hitting Johnny's next question was like, well, what if I didn't want to have it necessarily be peanut butter every time? Right? What if I wanted to have a filling, or not a filling? What's a better word for it? What do they have? The magic ingredient, right? And I can say magic ingredient here. Remove that. Do we think anything has changed? Really?
Yeah.
Okay, tell me more about that, Drew.
Do you pass the argument matching for sandwich maker?
Down on 16, you're saying? Yeah, perfect. Okay, so I could say here, instead of having fun, I'm going to call this ham and for this I'll say ham. Whoops. There's no keyboard shortcuts. Okay, and then for let's say I say turkey and sandwich maker. Turkey. Right. So just like how before, when it had access to the declared variable before that function, right? It still has that. It has that with now it will have access to magic ingredient and filling. So if I say ham and then I could say, and here I could write cheese, and I could say turkey and I don't know, what do they have? Mustard, you know?
Take out fun.
Yeah, that's a good idea. So I can say ham and turkey and run those and okay. So I've created these two different functions now, right? I can create different sets of sandwiches with different magic ingredients and different fillings. And I can create these functions incredibly quickly and easy. Because all I have to do is call sandwich maker and pass in the magic ingredient. And then I can call that variable and pass in any filling I like. Questions on that? Or I could do the same thing here. I could say,
Closures only have two functions.
sorry?
Closures only have two functions.
Well, the concept of a closure is a function that's using variables that have been declared in the scope prior to the function. That is like the definition, and it's these three things that we're looking at. So the first thing that we looked at is functions can refer to variables defined in outer scopes. Closures can outlive the function that creates them. So even though sandwich maker has been fired, we can still continue to use this reference to those variables, right? Oh, that's going to print out cheese twice, but I could say Swiss, so I'll get more specific with cheese. and it's okay, right? So this is a really a good way to create lots of functions that have some similar capabilities but are a lot more flexible. Any questions on what we're saying here? Okay. So the third thing that I want us to remember, so I'll comment these out for fun for now. And our third thing I'm going to say is 3 closures internally store references to their outer variables and can both read and update their stored variables. Okay, so closures internally store references to their outer variables and can both read and update their stored variables. Yikers, what's that mean? All right, well, let's make a little example of a box. Let's say I have a function called box. And inside of this, I have a variable. I say like let value, and I'll initialize it at undefined. And then this is going to return an object, okay? And this object will have the following properties. It's going to have set, which is going to be a function with a new value. And it will be value is equal to new val. Okay. We're going to have a get. It's going to be function. And that's going to return our val. And we're going to have a type. Say function. And that's going to just return type of val. Questions on what our box is? Right, so this is a function that returns an object. That object has a value. Well, let's get more specific. So this function has a variable called val. Okay, that's the first thing. And it just has that. After that, it just returns an object with 3 keys. Those keys being set, get, type. And the value of those keys are functions. Right, so the point of this is that closures are keeping track of the reference to the variable and not to the exact value. That's the point of what we're going to be making. And this is one of the reasons what makes closures very cool. Okay, so let's do a quick demonstration of what this looks like. So I say let B equals box. Okay, so I've now, so what do we think B is? If I console log B, what's it look like? Does it look like a function? One guess for a function, any other guesses? An object? Yeah, right, well what's box return? Box returns an object, so when we log box, it's probably going to be an object. Specifically, I don't know if you guys knew what I meant. If you knew what I meant, you got it right. I mean, if you knew what I didn't mean, but what I wrote, you got it right. If you knew what I meant, John, then you got it right. So box itself is still a function. B is an object. Right. That was totally my bad. I didn't mean to write box again. Okay. Right. So our B is the return value of our box, which has set, get, type, which are all these things. So this is what gets kind of interesting. So if I say B dot type and I invoke it, what do we think that's going to give us? Janelle is undefined. You said function. Oh, you think Janelle's right? You've persuaded him. Nice, excellent. Yeah, I agree with you. It's going to give us back undefined. Okay? Because it's looking at our current val, which was declared when our function before our return. So this is kind of fun. So now if I say, so I'll do the console logs instead because I think it's a little easier to maybe read some of this. Okay, so console log, and then so now if I say b.set, and I say I want to set this at 98.6, temperature of the human body, right? And then I say console.log b.get console.log b.type. What are we going to get? What's going to print? Okay, so let's go, because there's like a few console logs here. We're going to stop this one for now. What's this one print? Undefined. Then what's this one print? B.get is going to print. Okay, how come?
Because it's still the value, it's asking for the value. It's gonna print the value, and the value is still undefined.
Well, what did this
Oh, wait a
line do?
minute.
Okay, I'm going to let Trey go for it.
Because 137, yeah, she said the value, it's in console, actual value is 98.6. Oh, yeah, good.
And then what's this going to print?
I voted.
Okay, let's give this a shot and talk about it. Yeah, so we got undefined, 98, and number. Do we understand why that's cool? Right? No? Okay. That's totally fair. Right? This is cool because this function box ran. It's done, and it just had a variable inside of it. And these other functions are still alive and looking at a reference to what that variable is. It kept track. Like when we're firing this function, which has already been returned, it's keeping track of the value of that val. That's what makes this pretty cool. Those are the main, these are the three main things of closures, if you can remember. Functions can refer to variables defined in outer scopes. We've seen that. Closures can outlive the function that creates them. So that means sandwich makers, already been fired. It's done, but yet we can still see it. And then closures internally store the reference to their outer variable. So if that outer variable gets changed, the closures variable also changes and can both read, update their stored variables. Because otherwise, if it just kept track of what it was when it was created, then if it got changed there, it still would have said value is undefined because our when this was created, value was undefined. But instead, it just kept a reference to it. So when set updated it, we actually were able to get the new value. That is awesome. Yeah.
What if, you scroll up,
Hmm?
the variable, no, not, yeah, 926?
Yep.
What if that was at 924, like outside of,
If line 26 was at line 24,
like, could that exist outside?
let's see what happened. I think that will be okay. But it might be weird. We'll see. Yeah, still works. But because it's still just within the scope of when this function was created, which means it's also accessible from here. Any other? That's a great question. Trey, I saw you had a hand up for a second too.
No. I'll check that quick.
You forgot that. Excellent. Max, is this clicking or you just fall asleep? All right, no worries. Okay, so let's try to create something of our own. I want you to, I guess I'll write the instructions of my goal. Try to do it without looking at the old lecture, because this is something I'm gonna quiz us on something we did in the old lecture. So I want you to create a counter function that allows me to count. So what do I mean by that? I want to have like you to be able to create counter as a function. And then I also, after this, so I want to be able to go const counter 1, and I want to be able to say create counter. And then I want to be able to say counter 1 dot increment. And I want that to return the current count. Yeah, Trey.
Are you implementing that one?
Yeah. Great question. Are those instructions kind of clear? So I want you to, this is hopefully more clear. I want you to set something up where you can say, I can create a variable and call our main function, create counter, and then I'll be able to continually increment it every time I call increment. So for this, you might want to think about, it doesn't have to return an object. I guess you could probably set it up so that it does. But also, I don't know, maybe just return a function similar to our egg sandwich and fill it in. because you're less. So you're going to want to do so outside your phone.
So this should be outside.
Request to see the sandwich. So they're just going to be a little line. You're going to want to return an object where you're going to return function. What function? So
They're like pop up and shoot up. It's closer to the truth. Cool around here. Actually, you're doing that. That's what it is. This is when you're asking for trouble.
I thought my resume sent.
So let's look at that.
Return capital. Yeah, we're returning. Capping it.
These are all same. It's a good spot.
No, it's
So we would.
we need to set. Yeah. How they be.
Accounts haven't changed yet. Whatever.
Make sure that's. Okay, so let's talk about this. Saw a lot of people get it or come very, very close, which is super exciting. Thumbs up if you felt okay doing it. Okay, some side, down, mediums. Yeah, okay, cool. All right, this is like, closures are cool though. I mean, they have a really high intimidating factor to them. So that's cool, right? That's like the rock. But inside they're just pretty cool. Probably also like the rock. So, okay. Shout out. So I miswrote this originally, so I'm going to write it a couple different solutions for a couple different ways people wrote it. Okay, so apologies for that. I was mixing a couple things. Okay. First way I'm going to write it is as if we didn't make a sandwich. So this is the way Trey was going for it, and this was the way you were going for it. So we had our function here, and we said, okay, function create counter, and we didn't need to pass anything in because we wanted to start these counts from 0. We go, okay, that's great. So we're going to say let count was 0. Question so far. Okay, so then we decided we were going to have this function called increment. So I could write it like this. Function increment. And what this was going to do is it was going to take our count, add 1 to it, and then return our count. And then here, I can return increment. Okay, this is one way to write it. So then, when I say, all right, we're going to say const counter 1, and I'll say this is create counter. So now create counter returned what? What is counter 1 right now?
What is the function create?
Sort of. Counter 1 is the return value from create counter. So let's console log it and see what happens. Counter 1. There we go. Remember, a function can return anything. It can return a string, a number, an object, an array, or even a function. Thank you, Trey. It's like we're thinking the same thoughts. Yeah. It's like you can read my brain. Yeah. Just kidding. Okay. So Janelle, let's look at this. So we say, all right, create counter is this function, and this function is going to return this function, right? So another way that I could write this, and maybe it would be a little bit more clear, is I could comment this out. Instead, I can write a return here, right? Create counter, when invoked, returns this uninvoked function. Does that make sense? Okay. Now this uninvoked function keeps a reference to this variable because it's within its scope. So that's pretty cool. So now we can see, again, I'll run it. Our function is increment. Now, some people might say, do you even need to name that function? No, right? I don't need to name it because I'm naming it here counter 1. So maybe I'll just make it an anonymous function. So now we'll say function, or just function, I guess. It's just function. You still with me? Right? We're returning this anonymous function, but here we're giving it this name, counter 1. So if I say, hey, let's actually increment it, increment our count, I can invoke it. Because counter 1 right now is a function. So if I invoke it, it will invoke this function, which increments our count and then returns our count. So what do we expect to log on the screen? Yeah, right? 1, 2. Still with me? With me? Everybody's with me? Okay. So another common mistake I saw here was this. People went plus plus, and they went, what the heck? It's 1 behind. Why? Why is this 1 behind? Okay. But why is this? Why? What's the difference?
To return before it has the value.
Yeah. That's pretty much right. So when we have our plus plus on the right side, as we do, it's going to return this count before this has even had a chance to activate. If I put count on this side, it increments first. Right? That's like a fun little JavaScript trivia kind of thing. Doesn't really come out necessarily all the time unless you're looking for a shortcut. More likely than not, you would see probably written like this, because honestly, it's less confusing, right? There's no doubt what's going on. Instead of like, well, which side is the addition on? How is that going to evaluate? Right, like this doesn't matter what side I put these on. So I'm going to leave it like this for the example. Questions on this way of writing it? All right, so let's talk about another way. So it's funny because we have like 4 people actively doing it and a half, but we like split into 2 ways. So like 2 people were attacking it this way, the other 2 people were attacking it the other way. So that was really cool to see, and that just shows the disparity that happens when you don't give perfectly clear directions. Okay, so let's play again. I'm going to comment out this sucker, and I'm going to say, oops, that's not the same hotkeys that I'm used to. So I'm going to say function create counter, and it starts off the same, right? I say let count equals 0. Oh my goodness. Okay. And then what I saw, which was pretty cool, is people using the box example. They said, hey, return this object where we have increment. And that's going to point to, write a function. And this is going to do count plus plus, return count. That was one way, right? And then we'll see what happens. Okay. So now I can go const counter 1. I'll say create counter. Okay, so right now, if I console log counter 1 this time, what do we get now? Object. Sounds good, Trey. I like that. We get this object with this function that it. So if I want to increment this, I can say console.log counter 1 dot increment. I get 1. All right, and I can write it again. Oh my lord. Okay. And we'll get our 1 and 2. And we go, okay. This is working just like the other one, although the way we invoke this is we key into it through dot notation at a property and invoke that function, while the other one was we were just returning a function that we would just keep invoking. Right? Both are really cool, and both are really good things to know. It just depends on what you want. I guess I actually like this one more. And the reason I like this one more is, to me, it feels a lot more flexible, right? Because I could have a reset. I could add a reset, this function, and then I could just say count back to 0, right? I could have a decrement, that, here, I'll switch up the notation here. In real life, don't switch notation when whatever you're writing in. I'm just doing this as an example of like, don't forget that you can do something like this. And then maybe I'll have a like retrieve property to it, or like show. And that will just be count. Right, something like this should work. So if I could go console log increment, and then I could say console.log counter 1 reset, console.log counter 1 dot decrement, console.log show. Oh, reset doesn't return anything, so hang on. Log show. Okay. What do we expect to see? Let's take a minute and think about that. And then when you feel that you know, throw up that hand, let's do it. Yeah, Janelle. Okay, speed demon. What do we got here? What's this line?
You're gonna show the function,
Okay.
and then 1,
Okay.
2,
Yeah.
0,
Okay.
0,
0. Yeah.
-1,
Okay.
-1.
-1. Anyone think anything different? I think something different. That's right. What's it going to show? What's going to log? So I didn't make a return statement on my reset of any sort. Like these have an implicit return because I'm using fat arrow and no braces. This, I didn't put a return statement, so I think this is just going to print undefined. But besides that, that like trick that I threw in, so now you killed it. Pretty sure that's, I think, the same thing. So function 1, 2, undefined 2, -1, 2. So there's a bit of an, wait a minute, that's kind of weird, right? Why is show showing 2? I actually don't know. 2.
That's a weird increment, line 73, that was the last time. So it just shows, no, it should reset. It's remembering the
Yeah.
last one, was the last one.
Yeah, it's seems a little weird to me. Oh, well, this is also mistakes, right? I'm doing counter. Okay, I see what happened. Our reset set counter to 0, not count. Our decrement subtracted counter, also something that's not there. Try it again. That looks a lot better, right? Okay, 1, 2, and the food's going there. Okay, 1, 2, undefined, 0, -1, -1. So essentially what Janelle said. So see, that was a good way to make a little mistake. Counter count, that's confusing. So this, this really might show you like a lot of ways that you have access, right? This is like, we've got this counter object essentially, right? This is like kind of object oriented here. We created this counter object with all these methods on it that we can call, and that they just update the current state, so to speak, of that object, right? That's pretty cool. So just to recap again what we've got so far, functions can refer to variables defined in outer scopes, right? This is like the foundation. Closures can outlive the function that creates them. So even after that first function has run, whatever that function, the next function, that closure function, still has access to those other variables. And closures store references to their variables that they can update and read. Right? That's a big deal. Okay, so the last little challenge I want for you is I want to be able to call a function that says, well, I'm going to give you two challenges. One's going to be say my name, or I'll do it like this. I'm going to say greet me. I want you to write a function called greet me that takes in my first name. So if I write Corey, and then I write a greeting of some sort, so I'm going to say hello. I want this statement written just like this to return hello, Corey. Okay? Just like that. I want it to be written just like that. Okay? It's not so as far away as you think it is. Just want it to be just like that. Whatever you have to do internally is up to you. And then, yeah, I want to have just a general greeting. Yeah, that's fine. I'm just going to leave it as, yeah. Johnny, I think you're right. I think this will be better for what I want to show with once we get this example out. So I want it to be hello, Corey, invoke like that, and then return hello, Corey. Good catch, John. Like, it's fine the other way, but for what I want to do next. This will be the last little. So think about that first way that we did that. That first way we might have been mixing up how this really isn't too perfect. But it was just stitched together.
It's pretty fascinating concept, but like you can update from other functions where so I'll quickly go through it now.
All right. How'd this one go? Yay, nay, okay. Yeah, overall, pretty decent. Yeah, so I saw a lot of pretty exciting stuff there, right? So just gonna go through a couple of the different syntaxes, right? So we had function, right? We can write this in ES6, right? I could say function, greeting, and this took in like string 1. And then I saw a couple different things, right? I saw function, like second greet, we could say, took in a string 2. And then this return of, I'll just put it in like this. Saw some concatenation, but I also saw this in somewhere, so I'm just going to show everybody a couple of things. Whoops. Right? And then down here, I saw people, and then here, we have to still return something from greeting. So I saw somebody go like this, return second greet. I think this is Johnny's code mostly. And excuse me, console log greeting. And we said hello. And for the next one, we say record, right? And right, it works. So what's like? Let's break down what's really happening, right? We call greeting with the argument hello. This is the first thing that's evaluated. This returns this function. We then immediately invoke that function and pass in that string 2 argument and return that, right? So that's how that's happened. So instead of writing it down here, right, could have also just been return here. Same thing. Right, we can also ES6 this a little bit. Right? I could say const greeting equals, right? That's kind of cool. And then instead of that, I could return an anonymous function, right? There's no need to actually name this if I'm just returning it. I have to name it if I'm going to call it down here and return it. But if I'm not going to do that, I might as well just do that. So now we got still working. That's pretty cool. Right? We can simplify this even more. I can get rid of this curly brace. And now I can get rid of the return because I'm just implicitly returning. So that's getting pretty slick looking. And I could do that again here, right? I could return, get rid of this curly brace. And therefore get rid of this return. And now we've got a really slick looking function. All right, that's pretty cool. This might look kind of similar to when we did action creators. asynchronous action creators in Redux. We had like a function that would dispatch, which would fire another function that took in dispatch as an argument, which then did the utility call and then dispatched that information to our reducer, right? That was an example of using a closure. So yeah, we could do it like this. We could do this like fancy greeting, right? But I could also do something like const what up, and I could just call greeting and say, what's up? You know, I could have a const top of the morning, which is greeting. So we say top of the morning. Right, so now I just created, from one function, I just created two quick functions that have different types of greetings. So I could say, what up? And I could say Trey. Right, and then boom. Oh. There's something going on. Reference error, Greeting. Yeah, that will do it. Another error. Reference error, what up? Yeah, that will do it. Third time's the try. Yeah, so we get what's up, Trey, right? We could also do top of the morning. Two birds, one stone. John. Right? Pretty cool. Just to give you like a little bit of a taste out there. Be sure that you can make your own increment count, like calculator counter and stuff. Something like that sometimes can show up on an interview. I know some people have had that. Know what a closure is. Really decent question that someone might ask you in an interview. It's like, hey, what is a closure? How can you use it? How can you write a closure? Right? And we saw those examples. Those three things to remember. One more time, functions can refer to variables defined in outer scopes. That is key. Closures can outlive the function that creates them. That means even though that one function's been returned, our current closure still has access to the variables that have already been declared within the scope. And lastly, closures internally store references to their outer variables and can both read and update their stored variables. If they didn't keep track of a reference, then in our box example, even after we set it, when we went to get it, it would still have said what it originally was, right? Because that's what it, but because we can update it through set and get is just keeping a reference, that's how we can still look and monitor and watch those changes. Any final questions? Do we feel better on closures? Yay. Worse? The same? All right, cool. Nobody got worse. Another victory. All right, great. Awesome. I will stop the screen share.